Okay, solving a problem like this could get pretty tedious if you don't have a tool like Desmos. So that's what I've used here to give you some ideas on how to solve this problem. You might want to pause the video here and there to get copies of exactly what's going on. But the surveyor starts here at point A with coordinates 0, 0, moves to B, a certain distance in a certain direction, moves to C, moves to D, and we want to find out, once we've got the coordinates of D, how far she has to travel to get to A, and what direction she has to head to get back to her starting point. And then we want to find out what the area of this green region is. So the idea is to use the fact that the coordinates of point B will be based on the cosine of this angle right here, which I've labeled a sub 1, will be the x-coordinate, and the sine, multiplied by the hypotenuse, I should say, will give us the y-coordinate of B. So here's the steps to find the coordinates of B. The distance from A to B. Now notice how I've written this as inches. I've converted to feet. So there's a decimal representation for the distance from A to B. This angle right here is 28 degrees, 5 minutes, which is the same as 28 plus 5/60 degrees, or 1/12. And to find this angle right here, which we want to use that angle because when we take the cosine and sine of that angle, we're rotating from east in a counterclockwise direction to get a positive angle. So that's what a sub 1 is. This 90 degrees right here, take away this angle that was north 28 degrees 5 minutes east. Okay, and now x sub 1 is the distance from A to B times the cosine of this angle. That will give me the x-coordinate of B. And y sub 1, the y sub 1 is the y-coordinate of B, will be the distance from A to B times the sine of a sub 1. Now similarly, we can do the same thing to get the coordinates of C. And what we're going to be doing is adding the x-coordinates to get to point D. It's like vector addition. And we'll be adding the y-coordinates of A, B, and C to get to D. So here, is a table where I show how to find the coordinates of point C. And this distance right here, let me get rid of this. This distance right here is the 343.625. And if you picture a little horizontal and vertical segment here, if I put 343 right here, we know that this angle right here is 58 degrees, 2 minutes east. North, 58 degrees, 2 minutes east. So this angle will be 90, take away that angle. So this little angle right here is 31, close to 32 degrees. Again, this is the horizontal. So the coordinates of C are 343 times the cosine of 32, which is what this is right here, I sub 2. J sub 2 is the y-coordinate. Add I sub 2 to x sub 1, j sub 2 to y sub 1, and you've got the coordinates of point C. Okay, and now if I go to board 2, we're going to do a similar thing to get the coordinates of point D. And notice to get a positive angle, this is the little 4 degrees, 1 minute or whatever, 11 minutes. So it's south, 4 degrees, 11 minutes west. To get this angle as a positive angle, we're going like this. So we're subtracting that little 4 degrees from 270. And there's the coordinates of point D. Add to x sub 2 and y sub 2. We've completed vector addition for 3 vectors. And we've got the coordinates of point D. And here they are. And to get the distance from D to A, we're actually finding the magnitude of vector dA, or you could just use the distance formula, which is, I showed that on the next board. But to get the magnitude, or the direction, we have to find this angle. And to do that, find the slope of that line right there by putting y sub 3 over x sub 3, because we're changing y, change in x will be with the point 0, 0. And the inverse tangent of that slope will give us this angle right here, negative 53 degrees. But if we subtract 53 degrees from 90, that'll give us the size of this angle, which is 36.7. And because if I draw a vertical line through point D, these are alternate interior angles, so we can say that the direction from D to A is north 36 degrees 44 minutes west. Okay, and obviously the distance from D to A will be the square root of this plus the square root of this x coordinate squared plus the square root of this, the square root of this x coordinate squared plus this y coordinate squared. And if you want to find the areas of these triangles, there's 2 ways to do it. Of this region in acres, there's 2 ways to do it. There is a formula if you want to use the vertices of the quadrilateral. You can do a search on Google for finding the area of a quadrilateral when you know the coordinates. I'm not going to go through where that comes from, but it looks like there's 43,560 square feet per acre. So if I divide the area in square feet by square feet per acre, that's the number of acres right there. And if I want to instead use Huron's formula, I can draw this diagonal, find the length of that side, and that's what this is right here. Use Huron's formula, find the semi-perimeter. There's Huron's formula for the first triangle. There's Huron's formula for the second triangle. Add them together and divide by the square feet per acre. I get the same result as I did over here. Okay, I didn't post the answer for the distance from D to A, but you'll see it if you visit this link after the video is posted. There you go. Hope that helped. If you have any questions, post a comment.